Okay, so welcome everyone. I'm Herbert Winful. I'm a professor in electrical and computer engineering. And thank you for braving the weather conditions, icy roads and everything, to come to hear our Willie Hobbs distinguished alumni speaker today. So first, I'll tell you a bit about Willie Hobbs. So Willie Hobbs, the person that this lectureship is named after, was the first African-American woman to receive both an undergraduate degree and a master's degree in electrical engineering from the University of Michigan. She did this in 1958 and 1961. Then she worked for a few years locally, and then came back to Michigan to get a PhD in physics. She became the first African-American woman in the country to get a PhD in physics. And she did that also at the University of Michigan in 1972. After that, she worked as a research scientist at Ford for several years as an assembly engineer, where she expanded Ford's use of Japanese engineering and manufacturing methods. In 1991, she was named one of the 100 most promising Black women in corporate America by Ebony magazine. So I'm pleased today to introduce my friend, Christopher Rutledge, as this year's ECE Willie Hobbs Distinguished Alumni Lecturer. Chris earned his bachelor's degree in electrical engineering at Prairie View A&M University in Texas in 1988. After that, he spent like 3 months at Bell Labs in New Jersey, and then came to Michigan to get a master's degree in electrical engineering, focusing on optics. Now, I'm happy to say Chris took my optics course sometime in 88 or 89. I was pretty new to this campus and still learning how to teach, but he still put up with me. And he impressed me with his question in mind, very deep question in mind, his joy of solving hard problems, and a passion for the real-world applications of the theory that I was teaching in the classroom. So then, armed with his master's degree in '89, he went back to Bell Labs, and he's had a brilliant career in optical communications and networking. He's now a distinguished member of the technical staff at Verizon. Now, clearly, Chris must have liked his experience at Michigan, because years later, he sent both his sons, Kwesi and Lee, to study at Michigan in electrical engineering and computer science. Kwesi just finished with his PhD in electrical engineering just last summer. And Lee is out somewhere on the West Coast applying his trade as a computer engineer, computer scientist. So please join me in welcoming our more distinguished alumni lecturer for this year, Chris Rutledge.
Thanks so much, Dr. Winful. Thank you so much, and thank you all for having me. Oh, geez, it was a great drive from New Jersey last night. 10 hours of fun in the water. Okay.
Oh my gosh.
Anyway, but thanks so much for having me. Hopefully I don't want this to go dim on me here. Okay. All right. So, on the second slide, I'll say, hey, my name's Chris Rutledge. But the first slide, this whole first slide just conveys the fact that I think all of you all, faculty, staff, students, are superheroes and the chosen ones. If you like to solve problems, if you run to some hard stuff, the gradient of this, the curl of that, the permittivity of free space, electron hole, anyway, if you run to those hard problems, you are the chosen folks. You're the chosen folks. You don't shy away from the road less traveled. There's something about that curious person. My grandmother used to say, you know what, Christopher, you learn something new every day. Unless you're dead. Because my grandma didn't have to get the unless you're dead thing. But anyway, so, but she lit a spark in me a long time ago, along with my brothers, to be curious and learn something new every day. So I take that as I go. And in today's talk, I'll talk about family, acquaintances, networks, and things like that. But I do believe we all are the chosen folks who do solve the world's problems. We're the intellectual first responders. We really are. So, I'm Chris Rutledge. I'm the third of three boys growing up in East Texas. I'm almost the shortest person in my family, just to let you know. Okay? Yeah, things grow big in Texas. So, I'm from Tucker, Texas. Population 200 people when I left. It's about 300 now. We got a population boom. Okay, so about 300 folks. And we're widely spaced in East Texas, by the way. Well, there's a legacy of pioneers, blacksmiths, and I got to throw in that Friday Night Lights thing. Oh, Texas football state. I'll pull something together real quickly. Pioneers. There's a book called True Women. A movie was made. Angelina Jolie was 19 years old when she starred in that movie. She was a character. Her best friend was a character. That was my grandmother's great-great-grandmother. That character, Angelina Jolie's best friend. That was Grandma Lachey. So, look it up, get the book, True Women, how women conquered the pioneer. Anyway, so the family migrated over from Georgia over to Texas and helped conquer the frontier of Texas, southeast Texas, San Marcos area. Blacksmiths, the first mechanical engineer, I guess you could say. I was helping my brother out with the speech. He's a mechanical engineer, but I still love him. So he was doing a speech and we said, Chris, where are we going to hide from? It's from Uncle Galilee. He was 7 feet tall. And what about this? I said, well, the original mechanical engineer was Joe Cephas. And when he started a new county in Texas called Hayes County, named after, it was a general who was in the state assembly. He had a buddy named Colonel Hayes. Colonel Hayes, I'm going to make you a county, man. This county needs a blacksmith. Next time you go to New Orleans, buy a slave for $800 and bring him on back here. That was Joe Cephas. So Dr. Kwesi J. Rutledge, the J stands for, now you know. Friday Night Lights, Uncle Joseph Rutledge, probably the smartest man I know, was the 10th grade principal at that school in Odessa, Joseph Rutledge. Friday Night Football is serious, but there's a Rutledge someplace everywhere, in Texas, doing some educational stuff. So I'm an electrical engineer. I love being an electrical engineer. Boy, if I'm not doing problem solving, I got a problem. If I'm not doing it. I had a good friend at Verizon who just retired. He said, Chris, I'm terrified. I don't have a hobby. He's a problem solver too. I tried to give him a hobby before he left, collecting coins or something. But anyway, but problem solvers need those kind of things to keep them challenged and going. So I'm an electrical engineer, love every minute of it. I apply it at work, at play, the whole 9 yards. That's what I do. I'll show you a slide what I do as a hobby. And then next slide coming up. I'm a son, dad, brother, uncle. For some reason, boy, it's a lot of dudes in our family. We got one girl cousin, one aunt. There's a lot of guys, just a lot of rough and tumble stuff going. But and I do. We talk about our family, talk about family history a lot. That perspective is really good. I remember not too long ago, I was at this, and I'm not fancy, okay? I was at a wine tasting. And the person who organized this said, I don't want you to sit with other engineers, sit with other people, please. So I'm sitting with a psychologist and a psychiatrist. And I'm thinking, boy, you really hit with the opposite right here. So he's talking, and I'm talking about the family structure and the teachers and back to Reconstruction and a bunch of things like that. And he's like, that's amazing, you know your history. I'm like, duh, because my grandmother would always tell us this. Late night, she'd come into her room and tell us about Uncle so-and-so and the blacksmith and another thing. And it was just like part of the thing. I said, it's no big deal. I said, no, it is a big deal. I said, doesn't everybody, if you don't know your family history, Chris, he got dead serious, you will go crazy. I was like, seriously? He's like, oh yeah. So I'm gonna acknowledge the people before me, my mentors and motivators. But that guy broke real serious. I didn't think he was gonna get this serious at the wine tasting. I just wanted to get them Moscato, D'Asti, but anyway, but that was good that he brought that up. I'll never forget that. I'm an inventor. When I was studying in undergrad, even before, you look in the back of those books, Bell Labs. Who invented this? The communication theory, Bell Labs. Bell Labs. Like, okay, what the heck is going on with this whole Bell Labs place? And I just wanted to be in those numbers, man. I just wanted to be with those Bell Labs folks who were doing this thing. I didn't know how, what you needed to do to be there, what you needed to do to get a patent. Did you have to wear a white coat? Was there a secret handshake? I don't know. But I wanted to be in those numbers, and I got there from undergrad. I remember the lady who hired me in, oh man, Patricia Webb, and my short-term memory is like shot, but I remember that stuff. But the lady who hired me in, so I hold a number of patents, about 20, I think, in optical communications, video compression, some software, there's a few things that kind of bounce around to help out. And I'm kind of behind on submitting a few software-defined network things, but I'll get to them this year, I promise. And I'm also a coach. So here's the thing. So long ago, my wife and I founded a track team, and then we became a coach. And you know, basketball is the family sport. And when Kwesi and Lee played basketball, I was like, maybe we'll try track because your mother's a runner. So we founded a track team. So in my spare time, the first 2 years of engineering, people, statics and dynamics, man, physics, what's happening? So here's the deal. He plays for Villanova right now. This was his pro day as a starting linebacker at Pittsburgh last year. He's a master's athlete who just does not know when to stop running. He's top 3 in the world in the 1,500 meters and 800 meters. I strength train. Miss Campbell, she jumps for Rutgers right now. And Team Puerto Rico, she's probably gonna be in the next Olympics. And she leg presses 700 pounds. They wanted her to run from Miss New Jersey. I said, none of that, you're not a beauty person, you're an athlete, stop that. I said, but if you did run, I want you to kill everybody up on stage, okay? But she didn't run. But that's Miss Campbell. Miss Christina, freshman year, Colgate, starting small forward. She's doing her thing at Colgate, and many Ivy Leagues, so she's doing her thing. Oh boy, this is my new Miss Wheeler. Miss Wheeler's about 6'3", she's a 9th grader. With her hair in a bun, she's taller than I am, and she doesn't know how to space herself socially away from Coach Chris. So she's something else. Not being a girl dad, I'm in new waters here, but she's something. Coach Chris, guess what happened to me? The coach from Michigan called me. I was like, please say state. No, the blue ones. I was like, oh Lord. so as a 10th grader, it's somebody Michigan is talking to her, but 6'3", she can leg press 800 pounds. And I wrote a white paper on strength training athletes. That's not even my thing. I'm an engineer, but I had nothing to do one year. And I was like, here's a white paper on how to strength train an athlete. Anyway, and this picture right here, I want, if it were Chris's world, everybody would react to you like the superstars that you are. So, front row here, Dr. Christopher Rutledge. He was 9th in the nation in the 400 meters. Here's his brother Lee, computer science master's degree, 4th in the nation in the 400 meters. Here's Minka Fitzpatrick, the highest paid safety in the history of the NFL, playing right now for the Pittsburgh Steelers. I want everybody to be hyped like they when they hear that. The engineers, we get hyped for the engineers. Let's give it up one time. Okay. So anyway, mentors and motivation. Now I'm an engineer. I ride motorcycles. I'm getting rid of that motorcycle. I play basketball. In different segments of my life, have mentors and motivations in each segment. For engineering, though, I'll run through a few. Miss K is my mentor from Prairie View A&M University. I've called her Miss K since I illegally went to Prairie View as a 10th grader taking college hours. I shouldn't have been in that program. She calls me out on that to this day. I didn't have a transcript, therefore I should not have been enrolled, but I took courses early, and it's a little precocious thing, but she supported me there. And then later on, before I graduated, she moved out because she got married to who we call, Doc Winful, some dude up north. That was Mr. Derek Scott, who just retired from the College of Engineering. So those two are my mentors, for the longest time. So they've helped me through. And listen, my engineering mentors and motivators, about half of them are not engineers. Please remember that. Not everybody who's in your doggone support system has to be an engineer. Sometimes I'll run you into a ditch because you want to have that diverse viewpoint. So my grandmother, for sure, you learn something new every day. That was Grandma Johnny. That was her. Lieutenant Colonel Clyde. But I was doing some projects. Some of the most rewarding projects are those direct. You know what the end result is. You know what the mission is. This is Department of Defense projects. When I met him, and I respond to this, being a big old dude from East Texas. Hey, Mr. Rutledge, how's it going? We got to do a project. We got 6 months. Failure's not an option. Okay? I was like, I love that. his type of direct leadership left a big impression on me. There's no politics. We have to do it in 6 months. That's it. I love the kind of leadership. Ken Hartline, a very good guy. He was my master scheduler once upon a time. Very good guy. Helped me navigate through some politics and whatnot. Uncle Jay, Friday Night Lights, 10th grade principal, smartest guy I know right there. Dr. Rogers, never took him to mechanical engineering at Prairie View, never took his class, but he recognized in my family tree the engineering folks, the blacksmith, those folks. He recognized that and always praised us for that. I'm gonna talk about Dr. Akieri in another slide here. Jesse Russell and James West. Ooh, Jesse Russell gets a slide here too. He gets a slide here too. We'll talk about him later. James West, I have a number of patents. James West has a patent. The Lectureship microphone. Boy, if you ever had a patent, you want to have a home run patent. One dude I knew, my old office mate in Bell Labs, his neighbor invented the toothpaste tube. I was like, that's a home run. That's right up the green monster, man. Everybody uses a toothpaste tube. James West invented the Lectureship microphone. Back in the day, microphones were, on the phone, 2 diaphragms, carbon powder in the middle of it, and as you talked on the phone, the carbon powders would vibrate, that would modulate the electrical signal, and you'd have a voice call. When those powders got stinky, hey, I can't hear you. Oh, let me beat it on the table. Can you hear me now? Oh yeah, I can hear you now. That's how it was, those powder. James West, that dude, African American, that dude said, let's just stretch a thin piece of foil over this diaphragm and let that do it. Man, that was a home run patent. And just personable as heck, Doc Winful is on my list because when I first got here, coming from Prairie View, first of all, Prairie View's campus can fit inside North Campus easy. So when I got here, Mr. Scott was like, yo, this dude up here, Doc Winful, he just got here last year, man, he's serious. His theory's tight. I was like, what? And to see somebody like Doc Winful, I was like, oh man. Like I said, it's like looking at LeBron James or something like. I'm serious. I look at engineers and good engineers as like superstar athletes, superhero types, and not like Thanos, but good superheroes. So that kind of thing. So Big Rut, that's my brother. Mechanical engineer, has his own mechanical engineering firm down in Texas. It's crazy. He's about 3 inches taller than I am, by the way. So, but when I transitioned from optical research and projects like that, and I had to step into the whole thing of doing projects on a larger scale and terminating the optical networks inside buildings, he was my network that I went to for civil engineering, for construction, things like that. And that blend was nice. And when he just got elected to the board of a power, like Detroit Edison down in Texas, he's the first African-American, just got elected 2 years ago. He said, Chris, tell me about this whole power thing. I said, I got you, bro. I got you now. But he's in my support system as an engineer. That's pretty good. Josephus talked about him earlier. Tom Kennett, that's who hired me in the Bell Labs. That's who hired me in. As a matter of fact, around that time when Mr. Scott used to buy survival routines for professionals for all of his students coming to the University of Michigan, it would specifically tell you as an engineer, day number X on your first job, ask yourself and answer these questions. Week number X, ask yourself and answer these questions. Month X. That book, Survival Routines for Professionals by Tom Kennan, Mr. Scott gave that to all graduating seniors at the University of Michigan back in the day. And Dr. Kennan came and spoke to a lot of the students too. And he's the inventor of biconic connectors back in the day, the first generation of biconic optical connectors, my man. That's who hired me in. The Austin sisters, who hired me in as well. That was pretty good because they said, Chris, you're gonna interview with a few people today for your job at AT&T. They will ask you, do you want to go to grad school? You will tell them, yes, Chris. That's what you're going to say, okay? It sounds like Lieutenant Colonel Clyde. You will say, yeah. They really have that support system. Dr. Freddie Frazier, he's from the woods, so deep in East Texas, like I am. That was my math teacher in undergraduate school. The joke cracking, the humor, took all the intimidation out of the room for this country dude to take in some doggone differential equations and digest it. I had to absorb it, not adsorb it. So Dr. Freddie Frazier, I had to give him a quick shout too. Miss Aurelia, that's my wife. And all of y'all in this room right now, that's you. Anyway, next slide, sorry about that. So we're gonna talk about a few things today. The Fourier series challenge, Dr. Akiere, I was talking about that. We'll talk about the first project I had when I left grad school, fit rate, I had to learn about fit rates. I'm like, I want to do the optical thing, but we talk about fit rates, failure in 10 to the 9th hours. And also we're going to talk about It's your box, that bullet. What is that bullet about? We'll cover that too. That's my most favorite project of all time. You know, it was an optical amplifier. We'll chat on that one too. Also, watershed moments, because it was like an epiphany. Something else happened in the decision making in my engineering journey. Something stood out. That's why that's a bullet right here. Working for one of the founding fathers of wireless. That was cool. That was real cool. So we'll talk about him too. Also, floating networks in the desert. And also we'll talk about what I'm doing right now. So long ago, Dr. Akieti said, hey, got a challenge for you guys. It was first or second year, something like that. You guys, Fourier series, we want you to do a Fourier series, and I want you, group one, test your program on a square wave. Group two, test your program on a sawtooth. Group three, test your program on a sinusoid. Bet. I went to our computer lab and I lit that program up. I was group one, by the way. I was like, square wave, okay, good, square wave, I got my period, got my thing, amplitude. I was okay, done. So we sat down and said, okay, Mr. Rutledge, what have we got here? Show me what you got. I was like one of the first guys done. He said, okay, let me see. He said, pull your program up. Now, show me, I'm group one, show me the sawtooth wave. I said, no, Doc. No, you told me. What I told you was, I was like, what I told you was to do a Fourier series program, test it on a square wave. Now, and I saw Doc, and I spoke to one of his classes 2 years ago, and his daughter was in the class too. And he's like, Mr. Rutledge, I did that to you? I said, yes, you did, Doc. I must have had a bad day. It was two of us that day, Doc, with a bad day. It was two of us. He said, the highest I can give you is a B. I was like, you're really stabbing me right in the heart. but that made the bullet here to talk to you folks, because that type of thing, listening to what was being asked of you, he asked you to make the Fourier series program, but if he gave me anything, he wanted the Fourier series to represent that. He told me just to test it on a square wave. I designed a program and optimized it for a square wave. Wrong, Chris. Wrong. I remember that. When I got back from Michigan, I shared with some of the professors today, and I appreciate you guys' time. I appreciate your students' time at lunch. When I got back from Michigan, one of the things that I did, I got an optics, emphasis in my master's, because we were working on optics-based platforms. They were actually, and I Googled all this, and it's publicly available now, because back then I sure wasn't talking about it. But we were making systems that you plunged into the bottom of the ocean. Make long systems, throw them in the bottom of the ocean, and they listen for anything. That's what those systems do. Those systems transmitted all of that information back via fiber optic cable. So I was like, okay, all right. I was, okay, Chris, here's the problem statement. This program can have 0 defects. It has to be perfect, no flaws. I'm like, we got thousands of people working on this program. Somebody's gonna come in with a hangover. Somebody's gonna trip over. Somebody's like, you can't have defects, man. So if a defect occurs, this program is shut down. This was a multi-billion-dollar with a B program. It's like, okay, so now my pucker factor's up. So the service life of the system is 25 years, and you drop it in the bottom of the ocean. Okay, that's the next problem, next piece of the problem, okay. The optical transmitter had a 9 fit rate objective. The fit rate, here I am, I didn't know that, it's quality work. It's failure in 10 to the 9th hours. So 9 failures, I had to have less than 9 failures in 10 to the 9th hours. 10 to the 9th hour is 114,000 years, people. I can only have 9 failures and 140,000. So part of that evaluation was the transmitter module. You had a 3-axis G-Shock test. Bang, 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 bang. You're just shaking that thing around, and it's a fiber, and it's a solder blob, and it's a laser in there, and you're shaking it around. Now, let's temperature cycle it. We're going up and down and up and down. And to prove a system will last 25 years, y'all know Arrhenius. If you elevate the temperature on something and run it, you relatively age it. That's how you prove it's going to last 25. You don't wait 25 years for a program and they're going to be like, okay, get out of here, Bell Labs. So power measurements were always taken to be within tolerance. When we got to this test here, we started going on the borderline of some of those devices. It's like, it's getting close. It's getting close. we had to figure out in a program with 0 defects, what do you do? What do you do? Networking, talk to some other engineers, a lot more experience and things. You know what? Take a step back. What's the objective of the whole system? Not your task, Chris. Not your engineering task. What's the objective of the whole system? Oh, we're going to drop it to the bottom of the ocean. So this test is failing. This harsh cycle. Does that happen at the bottom of the ocean? Oh, no, it doesn't. Make a new category, call it a deep water laser code, and we're going to call it good. Ask the customer, is that okay? Customer's like, that's okay. Thank you. Thank you. Thank you. That was an interesting lesson because I was doing my engineering due diligence, my Pareto charts and my quality stuff, and I was like, oh, take a step back. That test was what we had to perform. But it's like, no, it's going to be at the bottom of the ocean. And I got to tell you guys, the whole thing, things, as I mentioned some of the professors today, in this universe, when you heat up things like bridges, concrete, wood, things expand. When you cool them down, they contract. Cool them down. Everything does that, except water. Except water. Keep cooling down water. It gets more and more dense to a point. Then what happens? Ice. The bottom of the ocean stays at 4 degrees all the time. Look it up. Look it up. So that kind of saved us. So anyway, that's a pretty cool thing. Now, my most fun project ever in the history of my work journey ever in life is, before this, somebody in Europe, I'd love to get the details, I forget which one, but somebody in Europe was doing some experiments with putting rare earth ions in glass. And it's like, all right, beam some light on that, and oh, wait a minute, hold up. Something's going on with this. I put this wavelength light, another thing happens. So somebody presented it and enlisted Bell Labs support to look into this whole thing. And we went nuts on putting rare earth elements inside fiber and glass and things like that. So EDFA's erbium doped fiber amplifiers. We dealt with neodymium, praseodymium, but we kind of settled on erbium there for a second because of the wavelength that we do for long haul transmissions. But this is the most fun I've had doing a project. It's never been done. There was one gent from happened to be from MIT. He said, "Chris, I'm leaving this project, and you can take the reins over." And I was bucking for a job to get in the lab and everything. And he said, afterwards, he said, "Chris, I didn't think that whole thing was possible, so that's why I kind of bailed." So that was crazy. But I went to conference in Albuquerque. So that's about 2,000 miles away from New Jersey, just about. And I went down there to meet a guy that worked 6 miles away from me. And I said, you know what, I got this project, man. It's a year-long project. The dude left 3 months into the year. I need some help. I knew the objective from the guy who had the product. He said, I need a fiber with these gain characteristics. And I said, it kind of need a bounding, and we're communicating. It's communicating like engineers, man. The characteristics gotta be here. It's not, if it were exact, somebody had done it already. I was like, it's gotta be here. I went through all the specifics of the noise and the gain and things like that. He's like, I just spooled some fiber at the end of February. And it might work for you. We get back to New Jersey, just let me know. So I told Doc Winful this at Zingerman's years ago. And I said, this guy, this physicist, man, it's David DiGiovanni. He said, I know David. We got a fraternity. Engineers and physicists, we got a fraternity because he knows David DiGiovanni. David DiGiovanni's fiber was perfect. I had to do some more engineering. It wasn't the exact fit, but it put me in the ballpark, and I took it right on to where it needed to be. So I made a multi-stage. The fiber itself wasn't working. I had to break the fiber, make a multi-stage fiber, multi-stage optical amplifier, and that helped me through. So we had high performance gains. We want to have a power savings because the system I told you about before, the undersea system, there was a multi-thousand volt DC power supply powering this system. The arcs and the ions you'd release just by powering this thing, if it ever shorted out, it'd be like lightning on the shore. We had to lower the power requirements. We had to get more bandwidth for higher resolution listening. So we needed to go with an optical amplifier and not an electrical to optical to electrical situation. That's why we were doing it. So it's good to know why we're doing these things. We're not just researching for the sake of researching. That's why we're doing it. So this thing, it took me 16 days, and I'm not even gonna play. That University of Michigan degree show did help me out. To do this in 16 days versus a whole year, you had to come with a little familiarity with this topic. I'm not even playing. I'm trying to say, oh, we go blue, but really straight up, go blue. So in the course of asking for help, and if I can get slightly, what was kind of cool with this whole thing, this is not my actual lab situation, but it looks a whole lot like it. We had an input signal, went through an amplifier. This curve here is called three things. It's called a gain curve, a noise curve, or amplified spontaneous emission. That's what it's called. It's good to know all your stuff like that too. So, little signal comes in, big signal pops out of that rascal. That was the first stage. I was like, I cannot go to the second stage with all this freaking noise, man. I'm gonna hit saturation. This thing's gonna be trash by the time I get to the other stage. So, bandpass filter, bang, right here. All that noise is gone. But I got a sack of noise right there. So it's like, how do we get rid of that noise where I'm mostly left with this? I don't fool with the Jones matrix, but that Poincare sphere comes right in handy. Spontaneous emissions are not polarized. This is. I knocked all that unpolarized stuff out. Bam, I'm able to hit that second stage smoking. We hit that 30 dB gain with a 9-volt transistor battery. Then my friend was like, Chris, let's put this in a briefcase. I'm like, why ruin a good thing? Let's leave. Let's drop the mic like Seinfeld and leave right now. Because it's like, but he said, put it in a briefcase, man. I said, we got to wrap the fiber. It's going to gain loss. But we put it in a briefcase. We didn't lose too many dB, in the briefcase and everything. But it allowed the program director to take that briefcase down to the Pentagon and get that money. He got that funny. On the airplane, it didn't break. Beautiful thing. So that's what happened here. The It's Your Box thing is this. I'm dealing with the world experts. David DiGiovanni, there's other folks in the lab who were just nice. It got to a point, not too many questions had to be asked. Chris, I don't know. You're asking a question about what happens with your first stage and second stage. I don't know. It's your box. I was like, the joy? I was like, that's right. This has never been done before. Well, whatever I say in this paper, so I did it. I published a paper. I was you're publishing in the Bell Labs journals and things like that. And one thing I didn't do is one of the old veterans at Bell Labs said, Chris, you published it. Did you go to conference? All my PhD candidates in here, you guys know y'all go to conference. I'm like, nah, I put it in the Bell Labs journal thing, man. I'm good, straight. Did you publish? Did you go to conference, Chris? I was like, he didn't have to really tell me twice. I was like, never let that happen again. It's not bragging. Get your work out there, go to conference, put your name and your your contributors, do that. So, but when he said it's your box, I was like, wow, he's handed over the reins because I respected these guys like LeBron and Michael Jordan. He said, no, I don't know, it's your box, man. Just wow. So that was a great experience for me. Now, Jesse Russell, here's the deal. Everybody has a phone right now. This is a 5th generation cellular phone, 5G, 5th generation. The dude who's responsible for 2nd generation is right there. That's the dude. And if you want to know a little bit more about him, I want you to look at this reliable resource called TikTok, and you will see him on TikTok. Look, TikTok, search Jesse Russell, and he'll talk about, hey, I was talking to these middle school, first thing he says is this. The first thing, I was talking to these middle school kids, and they said, hey, you're an inventor? You're a black inventor? I thought all black inventors were dead. He's like, it's not just about the peanuts, and it's like, he said, no, I'm living right here. He's still living in Piscataway, New Jersey, by the way. He said, and then he went further to state, when they were developing this technology, they were trying to get it to the baby bells. Y'all want to do this wireless thing? Nah, we're good. No, AT&T, you want to do it? No, we don't think that's going to. Even consultants were like, I don't know about this whole thing. So he says in his TikTok video that nobody really wanted it. So he had it to do something with it. Wasn't the popular, usually in corporate America, I can tell you this, sometimes the popular kids get the popular easy money projects, and sometimes This was not one of those projects. This is not one of at all. So he didn't sulk. He got to getting busy in that lab. And first generation was a lot of analog. Tuning in, I was telling Doc Winfrey, you can get a shortwave radio and I can tune in all your conversations. Be like, Doc Winfrey's talking about fishing, what? But the digital radio, that's where Jesse Russell came in, fast and furious. So he innovated, and he kind of taught me that he said, I left a lot, he has hundreds of patents, hundreds. So he left a lot of patents and innovation on the table because this is how I see the engineering journey. It's like, okay, you are a beginning student, and it's like, when you're real little, it's like, okay, Johnny, do this problem. Okay, teacher, the answer's 3. All right, you're a little bit older. The answer's 3 times x plus 5. You get a little bit older. The answer is the gradient of this field and the curl of that's, oh, geez. But over time, you will have a tool to get to an answer. Then you'll have a tool to make another tool to get to your answer. Then that kind of gets long. As you start getting into these parts unknown, my patent thing is this. I want to be here. Nobody's ever gotten here. I need to get from here to here to here to here to here. All of these steps are likely patentable. Nobody's ever done. You need to step, what did I do to make this tool? And then this tool, yeah, it's likely patentable. And a lot of with Jesse Russell, he left a lot of that stuff. No, I got to this thing, which is a major thing to protect and patent for the company, but he kind of left those other ones on the table. So anyway, respect this guy. As a matter of fact, he was the first hire from an HBCU in the Bell Lab. It's like an experiment, like, yeah, we're gonna get one of these guys from Tennessee State. We're gonna give these guys, see how they work out. I don't really freaking know. Then you gotta go on this boot camp called OYOC when you're on campus. So you make it out of there. Well, so he went to Stanford and lit Stanford the heck up, like the 4th of July. So he did pretty well and represented himself pretty well in Bell Labs. So floating networks in the desert. Now here's the thing, my journey is starting off with optical networks and things like that. We went through a lot of bursting with .com bursts and telecom bursts back in the 2000s and things. And I found myself, somebody saw on my resume, oh, guy does optics and stuff like that. Somebody gives me a call, hey, I need optical cable connecting some data centers. I'm like, that is really a stretch, man, but okay, well, whatever. So for a period of time, it was like, hey, we need some telecommunications facilities built in some really hot places. And so I had teams deployed in a couple of regions in Southwest Asia. And here's the problem statement. These are very large scale engineering efforts. They got to be out in the middle of nowhere, desert. There might be power, there might not be power. Give it a quick feeling for the scale of some of these projects. Hopefully you guys know what an ISO container is. Usually they ship big containers. The mufflers on my generator for the ISO container was 40 feet long. That's the muffler. Then here comes the motor. So I'm building these facilities for the mission that had fiber, Ka band, Ku band, microwave, troposcatter, old school, in the troposphere, ooh, old school. Anything, if I take out one, the second one steps up. If I take out the second one, and take out means I finish my whole project with, you gotta put a ballistic shield on this, Chris. What's that? Our allies make ballistic shields, so when somebody shoots it, oh geez. So anyway, part of the course. So all communication technologies are on the table, hostile environment, power and cooling are mission critical, provide a 2 megavolt amp, we'll talk about power factor, just say 2 megawatts, 2 megavolt amp, uninterruptible power supply, and hold up the building for 2 hours. There's the only quiz I'm going to ask you guys today. An uninterruptible power supply, you can buy them at Best Buy. You plug that box in under your desk, you plug your PC into that box. So if the power goes out, your PC stays up. That's a UPS. That's an uninterruptible power supply. That's it. Okay? You buy them at Best Buy. I got a 2 million watt power supply that has to stay up for 2 hours. So it's like, okay, I said, I got a question for you. If the power gets cut, your generators, they'll fire up and synchronize with each other in 45 seconds. How about if I just give you 2 minutes worth of uptime and call it good? Mr. Rutledge, we are not changing this requirement. I was like, why is my next response, call the civil engineer? Why was that my next response? Call the civil engineers. Anybody? If I cut the power to my UPS, how does it keep powering up my PC at home? What's in that little box?
Battery.
A battery. Chris Rutledge's experience was this. That is 100 tons of batteries in a desert on loose ground. The real answer was 70 tons. I said, I need a civil engineer now. That was from a little experience, Gab. I tried to back the customer. He said, we're not changing the requirement. And back when I had that laser code, I wasn't asking the customer to change the requirement. I was asking for a new code, and we would just deploy these hairy edge ones. This is different. I'm asking to change the requirement. It's like, no, we're not budging on that. But I have a good reason. We're not budging on that. I said, okay, bring civil engineers in. So, put a shovel in the ground. The water table was 18 inches under the surface. You put a shovel in, it's water. I was like, it gets worse. So, civil engineer, you need a floating foundation. I said, what? A raft foundation. The pad was 1 meter thick of concrete. The water table was right under there. All those 70 tons of batteries went in that room, and I was like, wow, I really love my civil engineers because they're not playing either, just like we're not playing. That worked. They pulled that off. So that was the thing. Was it my obvious thing? No, but it led to one thing. It led to nothing, and I'm networking with my peers, and we got that thing taken care of. So that's that. So right now, you see, this is not, hey, Chris trying to snuggle up Doug Winfield, make him feel good. Now here's the deal. When I got in from that lovely 10-hour trip, I was on the phone at 9 o'clock with my developers, and it was like, yo, what is going on with that meeting that happened? What the heck is going on? So folks I work with just love to work the problems. We love to drive the solutions. We'll pick up the phone any freaking time, and it's a passion. Sometimes when a professor gives you a hard assignment, you'll be like, they must have had a bad night. No. They might. Okay, I got to tell you one of Uncle Jay's stories. Uncle Jay's stories. And he told me this a long time ago, and I heard other people on the internet say it. But he said, hey, Chris, there was a bird flying, Chris, one time. And he was late flying south for the winter. And he got up there in altitude. It was a freezing rain situation. He fell down to the farmer's yard and couldn't fly anymore. So then, as he looked over there, the farmer's cow came over and said, oh man, it's a bird right here. He walks over here and the bird's frozen and everything. He's looking at it, and he turns around and he drops a cow pie on the bird and walks away. And the bird's like, are you kidding me? You're in East Texas, you know what a cow pie is. I'm not gonna describe it here. So, are you kidding me? But the bird's like, it is kind of warm though. Hold up. Oh, whoa, it's kind of warm. I'm kind of thawing out. I can get up out of here. He's chirping, and he's ready to go, and the farmer's cat sees him. He's like, oh, geez. So the farmer's cat comes over there, and he brushes him off, and he cleans you up, man, and he eats him. So my uncle's like, Christopher, not everybody who craps on you or gives you a hard assignment is your enemy. And not everybody who cleans you up is your friend. So, carry on. Welcome those tough assignments. And that concludes my presentation. So hopefully you guys got those takeaways from there. I never impose my style on anybody, but I put in red, this is Chris Rutledge's style. This is my style. And I like y'all. I usually don't get my trade secrets, but this is my style. When I talk to decision makers, not everybody's as technical as you are. Not everybody has the same field as I do, but I got a gift, man. I can break down the most complicated technical situations to where anybody, if this country born from East Texas, I'll break it down. It's like, holy crap, I kind of understand that thing. And then you will be able to carry the solution further. Chris, if I understand what you said correctly, then we should be able to do this. Yep. And now you own the solution as much as I do. And I might have been in the lab neck deep for 2,400 hours, and you just got to spin up in 20 minutes. And now we got skin in the game with each other. But that is my thing. You can read the rest later. Okay. All right. Any questions? Sorry.
All right.